Welcome to session 4 of the 4911 CyberKnights software training. Today we're going to talk about conditional execution. But before we do, let's have a review about session 3. In session 3 we talked about parameters, the mechanics of using them, the limitations, multiple parameters, using constants, and then overloading methods by having different signatures with different parameters. And then we had some material on methods that return values, non-void methods. Void methods return nothing. We looked at the math class, and we defined some of our own methods that had return values. And then we talked about using objects. In particular, we went through using the string object, which we've been using for a while now, but we at least finally explained it. And then we introduced the point object. And we talked about references and how that's different than primitives, how the values are actually literally there, but with objects we're referring to something that lives somewhere else. And dealing with multiple objects with multiple references versus multiple references to the same object. And then we talked about the subtleties of passing in objects as parameters into methods and how that's different than passing in values as parameters. Today our agenda is that we're going to talk about some looping techniques that are a little different than what we've looked at so far. We're going to look at if-else statements, some of the subtleties of conditional execution, and methods that contain within them conditional execution, and then we'll wrap up with an example, a body mass index software example. We'll actually write some code today. Okay, so the cumulative sum problem is something you're going to do a lot, where you're going to be adding up a series of numbers. You may be getting them from a user or collecting them from a sensor or something, and you just want to add them all up. One solution is to declare a ton of variables representing all the numbers you want to add up, and then do a huge expression where you add them all together. That's not a very good solution because it's kind of error prone, it's tedious, you're repeating yourself, and you remember, if we follow the DRY, or don't repeat yourself principle, anytime we're repeating ourselves we want to look for ways to optimize that. And so instead we're going to keep a running tally, which is the essence of the cumulative sum problem. We start in this code here on the screen, we start by declaring a variable called sum. And then we go through our for loop and we go up to this number, this maximum number, which is called total numbers. Just assume for the sake of this example that total numbers is defined somewhere outside this code block, and it represents the total number of numbers that we're going to process. Likewise, assume that this getNextNumber method is already predefined and it gets the next number from whatever source. It's not important, it just gets the next one we need to process. Every time we call it, it'll just get the next one. And so within our for loop, our first step is to get the next number, assign it to a variable that we declare within the for loop, and then to take our sum value, which lives out, or which was declared outside the for loop, and to add to it next number. And remember, the plus equals takes sum, adds next number, and then assigns the sum variable with the total. All right, and then after our for loop, we print it out. And this is a great solution to a common task. You don't have to be summing them. You can have a cumulative anything, really. The same pattern is useful regardless of what your actual operation is within the for loop. Another very common pattern is the fence post loop. It's actually a fence post pattern. It's named after it's named after fences, and if you can imagine like the pattern of a fence, it's a repeating pattern where you have a post and then a fence section and then a post and then a fence section and so on and so forth until you get to the end of the fence. But there's a problem, and the problem is that at the end of the fence there's a post. So we start with the post, we end with the post, but our pattern gets kind of messed up, and we can't fix it by reversing the pattern by saying, well, do the fence section first and then the post. In that case, we do end in a post, but then we've left out the post at the start of the fence. And so what we really need to do is have like something inside a loop and then something extra that runs at the very end or maybe at the very beginning. You can look on the screen right now, and we're doing that. We're using the same sort of pattern we did for the cumulative sum, but we're adding we're printing them out and we're adding commas in between all these numbers. And that's very very similar to the fence problem where we have number, comma, number, comma, number, comma, but we don't want to end in a comma. That's kind of dumb. It doesn't look right. And so we go through the list of all the numbers here, but we take care to stop before we get to the last one, and then after we get out of the loop, we get the last one, we show it, and then we do a new line. So this will work. This is great. Okay, so what if the code should only execute in certain circumstances? And this is the essence of conditional execution. You can kind of figure out what conditional execution means by just looking at the words. And so we have right here code that should only happen if the user has gotten a new high score, if their current score is higher than this max score variable that already exists. And so we do two things. We say, you've got a new score, a new high score. And then we update the max score with the current score. But we only want to do this if the user has exceeded the max score, not if they have tied it or they're less than. And the general idea of an if statement is that we begin by checking the test, which is very similar to the way that a for loop works or is structured, where we have these parentheses and something inside it. But with an if statement, there's only one thing inside of the parentheses. It's a test. And we check if that test is true. If it's true, then we execute the statements, the control statements, which is the body of the if statement. If it's not, then we skip the body of the entire if statement, and we resume executing after the end, after this closing curly brace. So if the test is true, do this. If not, just skip to the end and continue on. Okay, so here's an example, another example where we want to get the square root of a number, but it doesn't make sense for us to try to get the square root of negative numbers. We're not really looking to solve that problem. We only want positive ones. And so we put this check right here, this if statement, where we check to see whether the number we want to get the square root of is greater than or equal to 0. And then we pass it into the math square root method, which we talked about in the previous session. But here's the question, like, what should we do for negative numbers? If someone passes in a negative number in this code that we've written, we're going to, at the end of our if block, or if statement, the answer is still going to be 0. And we don't want to tell them that the square root of a negative number is 0, because the square root of 0 is 0. We're confusing things. We're actually giving an incorrect answer to a mathematical problem. Well, the answer to that is to use an if-else statement. And that's very similar to an if statement. Only now we have the same sort of starting situation. We check this test. If the test is true, we execute the control statements. And then we resume execution after the if statement. The only difference is on the no side. On the no side, we execute the else statements. And then, regardless which side we've done, we resume execution after the if-else statement. And so here's an updated example for our square root problem. So if the number is greater than or equal to 0, then we pass it into the math dot square root method. That's a static method, remember, and that's why we're referring to it this way with a capital M math class dot square root. And then if it's somehow not greater than or equal to 0, then we just return -1. -1 is actually a fairly common return value for an invalid answer. Like, you can't calculate, you can't return the correct answer for this, so you just return -1. And you probably should have, at the top of your method, put a comment saying that this returns -1 for invalid input. Okay, so greater than or equal to is a operator that we're using in this case, if the number is greater than or equal to 0. There's a lot of operators that we can use in these mathematical statements, or in these if statements. We can use the equals, which we've already talked about, equals equals. Not equals, which is an exclamation point, and then an equals, less than, greater than, and then less than or equal to, or greater than or equal to. And you can see some examples of statements that are using those operators and what their values would be. Okay, so now that we've introduced some new operators, we should reevaluate our operator precedence. And this goes from top to bottom here. So the first things that will be evaluated are these unary, and I don't even know if I'm pronouncing that right, operators. They're basically operators that are only going to operate on one thing. So x plus plus, or -5, or +7, or that should be minus minus. Actually, this one should be minus minus. Oh well. Then there's a multiplicative operators, which is times, divided, and modulus. These are evaluated left to right, the same as the unary. If they're at the same precedence in this table, then they're just evaluated left to right in the order that they appear in the expression, not in the order they appear in this table. And then after the multiplicative operators are evaluated, then it'll perform the addition and subtraction. These are different from these unary ones. These are like 4 plus 9 or 10 minus 3. After all the addition and subtraction is done, then it will evaluate the relational operators. So if you have 4 plus 5 less than 1, it'll evaluate the 4 plus 5 first. And then it'll see whether, then it'll return whether 4 plus 5, which is 9, is less than 1. It's not, so then that'll evaluate to false. And then after the relational operators are evaluated, then the equality operators will be evaluated, equals equals or not equals. And then finally, after all of those are evaluated, the last thing it'll do is it'll assign the result to a variable, if that's part of the expression. So here's an example of operator precedence. We just have 3 plus 2 times 2 equals 9. And so it'll, in order of our operators in the previous table, multiplicative is the highest precedence here, so that's going to get evaluated first. So we have 4. And then additive is the next highest operator in that table. So that gets this 3 plus 4 gets evaluated to 7. And then this equality operator is the next one in precedence. Is 7 equal to 9? It is not. So this whole expression that you saw at the very beginning will evaluate to false. Even though it's a mathematical, it looks like a mathematical expression, you're not going to get a number out of this. You're going to get a Boolean value. All right, so back to our cumulative sum problem. So here's a question. What if there are no numbers? Let's have a look at our code. In the case that there's no actual numbers, then total numbers should be 0. So our loop won't execute. Nothing inside here will execute. And we'll say the sum is 0. Is that right? I don't think we want to say that the sum is 0 if there's no numbers, because the sum being 0 is a special case, like for maybe the series of numbers was -5 and +5. There's only 2 numbers in the series, so -5 plus +5 is 0. Where 0 means something in this case, like 0 is a sum. We want the user to know that there were no numbers, and 0 doesn't necessarily mean there were no numbers. It could be an actual valid sum. And so the solution is to use an if statement. So we start with the sum of 0, and if the total number of numbers is less than or equal to 0, then we just say there's no numbers to average. So the user who's executing our code is going to see and know that nothing happened. We didn't get a sum that's equal to 0. There's no sum. Nothing was done because there's no numbers. And then in the else block, we do our regular cumulative sum. Oops, I have a stray equals in there. This should be sum plus equals next number. I think that's on the previous slide as well. Yeah, ignore the equals plus equals. It should just be sum plus equals next number. All right, so revisiting our fence post problem. Again, with the fence post problem, what if there are no numbers? So we're trying to create a comma-separated list of numbers. In this case, if there's no actual numbers, then the loop doesn't get executed. But our last thing gets executed here outside the loop. We're going to try to get next number when total numbers is 0. And then we'll print out the result of that. And we don't know what's going to happen if we try to call get next number when there's no defined numbers. Maybe that'll be an exception. We'll talk about exceptions some more later in this session. But regardless, this isn't what we wanted to do. This is wrong. So let's use an if-else statement. So inside the for loop now, we print out the number regardless. We always are going to print out the number. And then if I plus 1 is less than or equal to the total number, or to total numbers, then that means that we're not done with the list yet. And so put out a comma. If we are at that place, if we're about to hit the very end of our list of numbers, then just print out a new line after we've printed out the number. And this code will work. This will do what we wanted, even for the case where there's no numbers. It'll just print nothing, which is what we expect. All right, so what if you have like a series of tests that you want to check, like you have like a bunch of different conditions that might be applicable, and you want for each of those possible conditions, you want to execute different code. And you may think that you would do something like this. If this test is true, then you execute these series of statements. Or if this test is true, then you would want to execute these statements. Or if this test was true, then you would want to execute these statements. What's the problem here? The problem can be sort of illustrated with this flow chart. So we have our first test 1. If it's true, then we execute the statements. And then if test 2 is true, we execute the second statements. Hold on a second. The way that I explained the problem, these tests should have been kind of mutually exclusive. We were thinking that like test for our conditions, we were thinking it should be either test 1 or test 2 or test 3. But the way this code actually works, it's going to try all of the tests. And so you might have a case where you're executing all 3 code blocks. In the case where none of the tests are true, then nothing happens, and maybe that's fine. But this isn't what I intended. This is something else. And so we can't use that pattern. Unless this is something that we actually want to happen. If this is something that we do want to happen, if we want to check all of these tests, like they're not exclusive, then yeah, we do want to follow this particular pattern where we just put them in order. But if the tests are exclusive, then we want to nest them. So we have an if statement where we check test 1 and then we execute the statements within that block. Else, then within this else block we have another if statement, and then we execute the statements that go along with that test, and then another else block, and then within that else block we have test 3. So this will only execute one of the statement blocks. We're never going to have multiple blocks of statements executing here. This is great. Only it's a little ugly, and we probably shouldn't actually be doing this. There's actually a cleaner way, and that's by using else if. Anytime you find yourself looking to implement something like this, just do this instead. What we have here is logically identical to the previous slide, only it's much easier to read. If the test 1 is true, execute statement 1. Else if So this is exclusive. This will only check if this test fails. If test 1 fails, then check test 2 and execute the corresponding statement if it's true. If neither one of these is true, then you would check test 3 and execute them, the corresponding statement. Okay, and here's a flow chart to just illustrate what's happening. If test 1 is true, then we execute statement 1, and then we skip to the very end of the whole if-else block and continue executing. And if it's not true, then we check test 2 and execute the statements that correspond with test 2. If only in the case that is true, and then we resume execution after the whole series of if-else statements, and the same for test 3. So we're only ever going to execute one block in this case. Okay, now what if you look at this chart here, if none of these tests are true, then nothing happens. We just sort of skip all the bodies and go to the end and resume executing after the entire if-else block. But in many cases, you'll want to have kind of a default. If nothing else is true, then by default, do this. And that's where else comes in. So if you have a bunch of else ifs, you can always follow it at the very end with an else. And this statement block will only execute if every single test has failed, if it's false for all of the tests above. And it's really, when you see this pattern, just read this final else as default. Like this is what it'll fall through to or have a fail-safe. If everything else fails, then do this. And this is just an updated diagram where if we have no for all the tests, then we execute statement 4 and resume execution. And we cannot execute statement 4 if any of the previous tests have succeeded. You can't get to that statement 4. All right, so here's a helpful table sort of describing when you would want to use these various patterns. If you want to execute any combination of the controlled statements, then you use the sequential ifs. If you only want to execute 0 or 1 of the controlled statements, then you use the nested ifs ending in a test. If you want to execute exactly one of the controlled statements, like you always want to execute only one thing, then you have the nested ifs, but it ends in an else block. A very common error to encounter is failing to initialize. So if you look in this particular code, we're trying to accomplish a task where we have this label that we've called, or this string that we've called label at least, and if a number, some number that has a value is exactly 0, then we want to say the label for that is none. If the number is less than or equal to 3, we want to say the label should be a few. If the number is greater than or equal to 4, then the label is going to be a lot. And if you try to run this code, Java is actually going to say this variable label might not have been initialized. And why is that? Because the reason why is that Java isn't smart enough to know that this is exhaustive, that you have sort of accounted for all the cases that you wanted to account for. And so one way to make this error go away is by having that last else if statement just be else. So it'll fall through to else in this case and always do this if the first two if statements fail. So if it's not none and not a few, then it must be a lot. Another solution is that you can set label to an initial value. You could say string label equals a lot and then have all the if-else statements. Yeah, this is one way to make the error that you see, like such and such might not have been initialized. This is one way to make it go away. There is a subtle bug here, and that could be if number is negative. We'll get to dealing with things like that later on in this session. Okay, so object equality. We've already talked about how equals is a way to check whether something equals something else. So equality is actually it works differently for objects than it does for primitives. So for like int x, int y, you can check equals equals to see if they're equal to each other. But if you try to do it for objects, it's not actually going to work. And so if you look at this code here, we have a point P1 where it's x is 1, y is 2, point P2, x is 1, y is 2. So those should be equal. They're the same. They have the same values inside, and then we just say point 3 is point 2. Now, if we try to actually do the equality checks, the first one is P2 equal to P1, and Java is actually going to tell us that's false, that these 2 points are not equal to each other, even though they have the same values. That's kind of odd. But if we check to see whether P2 and P3 are equal, it's going to say, yeah, those are equal. So what's going on here? The problem is that we're using the wrong equals. We're using the equals that should be used for primitives, for the values equals. When you try to apply this to objects, it's only going to compare the reference. If you remember with objects, when we say point P1 equals new point, P1 is just a reference to the point that's floating out in memory somewhere. It's just pointing to it. It's an address. And so when we check equals equals against multiple variables for objects, we're checking to see whether the references are the same. And so if you look at our code, P1 and P2 refer to different objects. The objects have the same values inside, but they are in fact different objects. New point, that creates an object. New point, that creates a second new object. These references point to different objects. Now when I say point P3 equals P2, I'm saying this reference points to the same object that this reference points to. So these two references now point to the same object. If you wanted to actually check whether two objects are equal to each other, you need to check whether or not dot equals is true. Dot equals is a method that exists on all objects. So if we want to see whether P1 equals P2, then we call P1 dot equals, that's the syntax for calling an object method, not a static method. And then we pass in as a parameter the second object that we're, or a reference to the second object that we're comparing it to. And so this will check, does P1 equal P2? Well, they're not the same object, but inside they have the same values. They actually are equal. So this is going to say true. And then P2 and P3 are references to the same object. But the method here, the P2.equals, is still going to check, it's still going to execute that method and check whether the values are equal. Actually, in a lot of equals methods, it'll just it'll check the references first and it'll say they're equal if it's the same reference. But that's an implementation detail. All right, so remember for primitives, you want to use this equals syntax, but if we're using objects, if the type begins with a capital letter, then we need to use the dot equals method for comparing objects. Okay, here's another subtlety that we need to talk about, round-off errors. This can be really surprising when you encounter it in code. So let's look at what this code should be doing, what it's supposed to be doing. We start with a number that's equal to 1.0. So this is a decimal number. That's why we're using double. Double means it's a type of decimal. And then we go from 1 up to 10, and we add 0.1 to it. And you would expect it to be 1.1, 1.2, 1.3, so on and so forth when we output it using this. But what you're actually going to see is this nonsense. 1.1, that's what you expect. 1.2, and then a bunch of zeros, and then a 2. 1.3, and a bunch of zeros, and then a 3. So what exactly is going on here? So we need to go back to our initial understanding. Remember that numbers for computers are stored in binary. not in decimal. You're looking at this as though it's a decimal where it's actually stored in memory for the computer. It's stored as a bunch of ones and zeros. 0.1 is in decimal. It's a repeating sequence of digits, or in binary. 0.1 is a repeating sequence of digits. Just like if you try to divide 1 by 3 in our numbering system, decimal or base 10, that would be 0.333 forever. It's a repeating sequence of digits. Well, the same thing happens with binary, and it just so happens that 0.1, if you translate it to a binary number, is a repeating sequence of digits forever. But a double has a fixed size. It doesn't have infinite memory size. So eventually those digits are just going to get cut off. Okay, so let's look at this mess of an if-else statement. So you can kind of read through here. I'm not going to read through the whole thing, but we check to see whether the money is less than 500, and then we print out your money and we give a particular message based off of what it is, and then we say have a nice day. And if you examine the else, if, and the else blocks, we're doing very similar things. We're repeating ourselves again, and we don't want to repeat ourselves. So let's look at this and see what's actually different. Well, in each block, the first line is the same. We say you have, and then $, and then we add money. This is, remember, string concatenation, and then we add a space and left, so it'll be a nice little statement. You have this many dollars left. And then we give a specific message. This message in the middle is different for each block. But then we always want to be polite, so we close with the same have a nice day for each of the blocks. So let's do this. Let's rewrite this without repeating ourselves. Let's take the things that we do. Anytime you see this, if you see like an if-else statement where you have like the same things inside the blocks, then you should take it out. So that part where we print out how much money you have left, well, we're doing that in all cases. So just take it out of the whole thing, do it first, and then check the money amount and say what they should be doing, give the specific message, and then close it up with one time and one time only saying have a nice day. So yeah, anytime you see repetition in those if-else statements, try to take those things out. They don't belong in there if you're doing it for every branch. Okay, another common thing that we're going to do in programming is to try to get the maximum or the minimum of a bunch of numbers, and that's called a min-max loop, or a min loop or a max loop. So you can see this code here where we start out with the maximum of 0, that's our max, and then we go through and remember total numbers. We've already talked about this, and get next number. We're going to go up and check all the numbers. If at any point, if the next number is bigger than the current max, which starts at 0, then we say the max equals the next number. And at the end of our for loop, then we should have the max number. But the problem here is kind of given away by the last question here. What if the numbers are negative? What if all the numbers are negative? Well, the maximum of -1 and -2 is -1. It's still negative, but it's among that sequence of numbers, it is the biggest one. And if you try to put that sequence of numbers into our code here, we're going to lie and say that the max is actually 0. The max was not 0 in that sequence. 0 was not in that sequence at all. But the next number is never going to be greater than 0, so we're never actually going to overwrite max. So, well, what should we do? One solution is if you know what the lowest possible number could be, then you just initialize your maximum with the lowest max, or the lowest minimum possible number. That way, this test right here, where next number is greater than, or where you check to see whether the next number is greater than the max, as long as any number exceeds or is equal to that minimum possible, you're not going to lie. You're going to have the correct answer at the end. But the downside to this solution is that it requires you to actually know what the lowest possible number is, and you don't always know that. So there's a different solution, and that is to use the first number as an initial maximum. So in this case, we say, well, the max is initially just the next number in the sequence. And then in our for loop, we're actually going up to total numbers minus 1 because we've already processed one of the numbers. So we don't want to do all the numbers. We want to do total numbers minus 1. And then this is identical. If at any point the next number is greater than the max, which was initialized to the first number in the sequence, then we override it. At the end, we should have the correct answer. But in this case, this is actually not going to work if the total number, or if the variable total numbers is 0, like if there's no numbers in our actual sequence. And the reason why is that we try to, just like we did earlier and on a previous solution, we try to call getNextNumber before we check to see whether there are any numbers at all. And the way to fix this is to do the same thing we did back in that previous solution, to check to see whether total numbers is greater than 0 before we set this initial. And if it's not, then we give an error message. Okay. So that raises all this talk about like expectations and conditions, raises the idea of these two pairs of concept, or it's a pair of concepts. And these are preconditions and postconditions. A precondition is something that you expect to happen before a method is called, or before, like if you're writing a method, this is something that needs to be done before someone invokes your method. And then a postcondition is what the user should expect the state to be after they call your method. Like what does your method do is a way to kind of answer what a postcondition is. So let's look at like a non-programming example where we're sort of making cake. And there's sort of 3 steps. Making the batter is one step, and in order to make the batter, we need to have, our precondition is that we need to have a clean bowl. The postcondition, after we've made the batter, is that the bowl has batter in it, and the bowl is also dirty. Baking the cake, putting it in the oven and baking it, the precondition to that is that, well, we don't want to put an empty bowl in, so the bowl has to have batter in it, or rather our pan, we don't want to put in an empty pan, but we need to make sure that there's batter in the bowl because we're going to dump the bowl into the pan and then put it in the oven. After we've baked the cake, then our cake is baked and we've now made a dirty pan. You might think that like a dirty bowl is a postcondition of baking the cake, but it's not, because we didn't make the bowl dirty in this step. We made it dirty and make batter. And then our last step is like the last step in this table, not consecutively necessarily, is to wash the dishes. The precondition for washing the dishes is none. Like you can wash clean dishes if you want to. It's kind of dumb, but there's nothing stopping you from washing a clean pan or a clean bowl. But the postcondition here, what someone can expect after washing the dishes is that the bowl is clean and the pan is clean. At least if you're good at washing dishes. Or competent at least. Okay, so let's maybe we have a cake making robot. So let's say that these are all methods. Let's write a loop that will make a bunch of cakes. So you may think that, okay, we just go to the total number of cakes and we make the batter and bake the cake. So, well, what's wrong with this code? The thing that's wrong with this code is that if you look at our previous table, after make batter, it is true that the bowl has batter in it and we should be able to bake a cake, but the bowl is dirty. And that's not so bad initially, but the second time through the loop, when we try to make our second cake, it says that the bowl needs to be clean. We need to wash the dishes at some point. The other issue is that after baking the cake, it's kind of a very similar issue. After baking a cake, the pan is now dirty, and when we go back to the start of the loop, and then we get to bake cake again, we can't, because the precondition for baking a cake is that the pan needs to be clean. So Simple solution is after you've made the batter and the cake, you can wash the dishes. Now, you could actually put wash dishes before make batter and bake cake, and this would work just fine. But after you made your final cake, you would have dirty dishes and you won't have washed them. So that's just a small gotcha maybe for a different circumstance. We didn't say whether like we want to make sure the dishes are clean after we've made all the cakes. Maybe that's like the next person's job. Okay, so what do you do if your preconditions aren't met? Like if you're writing this method for baking a cake and you encounter a pan you encounter a pan that doesn't have, you encounter a bowl that doesn't have batter in it, or you encounter a pan that's not clean. Well, you can throw an exception. You could print out a simple error message, but an exception is actually a better example because an exception will stop execution. It will prevent the process from continuing. And the reason why that's important is that when you recognize a problem exists, you need to do something about it. You need to deal with it right away. That problem, if you continue processing, might cause something else, and then you have a chain of events, and it's hard to know what actually the original cause was. And you can encounter exceptions by doing lots of different things. One thing that you can do is is trying to divide 1 by 0. If you try to run this code, you're going to get this output. It's just going to say there's an arithmetic exception, divide by 0. Okay, that's pretty clear what we did wrong. So let's use this for our own code maybe. But before we do, let's look at this sort of sample. In math class, you probably talked about factorial. It's the exclamation point operation where you have like you start at a number and then you multiply it by an integer, and you multiply it by every consecutive smaller integer until you get down to 1. So the factorial of different numbers, like the factorial of 1 would just be 1. The factorial of 2 is actually going to be 2 times 1, which is 2, and then the factorial of 3 would be 3 times 2 times 1, which is 6, and so on and so forth. And so this code, as you look at it, should work. We start with a product of 1, and then we start at 2 up into I is up to just before n, and then we multiply our number by I. And you may ask, like, why did we start at 2? Well, it's because, like, the factorial of 1 is 1. We don't need to multiply. So if n is 2, then we should multiply 2 times 1 and have the product. If n is 3, then we'll start by multiplying 1 times 2, and then we'll go through again with 3, and then we'll multiply 2 times 3, we'll get 6, and return the product. And this will work for a number of any size, but we need to talk about weird inputs. What should happen if someone enters 1? Well, 1 isn't necessarily the weirdest input, and we've already kind of talked about what happens there. If 1 is input is n, then the loop doesn't execute and we just return 1. And that's great. That's exactly what we wanted. But what about the case where n is 0? Well, if n is 0, then we start with product of 1 and the loop doesn't execute and we return 1. That's actually okay. It seems weird, but it's actually okay because mathematically the factorial of 0 is defined as 1. That may be weird, but that's not our problem. That's math's problem. We're giving the correct answer. But what about numbers that are less than 0? What if you ask for the factorial of -1? That's where things start to get weird. And in our code, for anything less than 0, we're going to say that the answer is 1. And we could print out an error message and then return the answer of 1 or -1 or something like that. But we're kind of trusting whoever called our code to read the output of the console And that's not necessarily a great solution. So what should we do? Well, let's use an exception. And how can we go about using an exception? The same way that Java uses exceptions in its native code. So the way that we're going to do it, or an important thing to remember about exceptions is that they're just objects. They're just a type of object, and you're going to get an exception. You're going to create an exception by using the object constructor syntax. So you see the word new, and then you see the constructor invocation here with the left parenthesis, the right parenthesis is capitalized because this is the constructor. Constructors are always named the same. They're special methods for creating objects, and we've talked about this in our last session. They're special methods for creating objects that have the same name as the class that defines that object. And within the native Java API, there are a bunch of predefined exceptions that you can use, and one of them is illegal argument exception. And you can create a new one by doing this, or you can use an overloaded version of the constructor where you pass in your error string to give a little bit more information. So this will crash the code, and the user will see what line it crashed on. This will crash the code, the user will see the line, and it will get your helpful message telling them what they did wrong. Okay, so let's update our factorial code looking at what happens. If n is less than 0, we now have a check for that. We just throw a new illegal argument exception, and then we pass in an error. And so what this will happen is when we hit this line of code, we'll just crash if that happens. And that's exactly what we want to do. The person who called our code violated our precondition. We cannot give a correct answer in those circumstances. So just crash it, and then they can fix their code that's calling your code. All right, so return values. Let's revisit return values. This is return values, we've talked about these a lot, but previously I mentioned that you can have multiple return statements within a method. And this is the place where you can actually have them if you have conditional return statements. They need to be protected by an if statement or maybe a for loop, but we'll get to that. So in this case, we're writing a version of the max method that already exists in the Java native libraries, but we're going to write our own for academic purposes. So we pass in two numbers, x and y, we'll call them that. If x is greater than y, then that's the max, we return it. Otherwise, or else, then we return y. And like I said, you can return in multiple places, but they have to be exclusive to each other. Now, if you see code like this, just remember that else block, that if you have return statements in both of them, this is logically equivalent. This works the exact same way as this code here, where you just put the return statement after all the if stuff, and you don't have to have the else there. Which one should you use? There's not really a strong recommendation. It's good to use one or the other in general and not to switch back and forth because that kind of makes your code a little bit harder to read. Just kind of pick one pattern and stick with it. Okay, so a common error that you will encounter as you're dealing with strings, and we looked at the character at method in the previous session, is to accidentally go outside where the characters are in your string. And so we're in this case, we're trying to implement an index of method where we accept a character and a string, and then we're going to return the index of that character within that string. And then if we don't actually return anything in here, then we're going to return -1, which is okay. We don't need to throw an exception. People know that index of, well, when you get a -1, it means it wasn't found. So if you look in this code, we start at I = 0, and then we go up to less than or equal to s.length. This is the problem right here. If we go through the entire string to this number, s dot length, we're actually going to go beyond the end of the string, because if you remember, strings are 0 indexed. So the first character in a string is 0, the second is 1, and so on and so forth. So this should be length -1. Or you can convert this to a less than instead of a less than or equal to. Interestingly, this code will actually work. This bug, you might miss this bug. This code is going to work in pretty much any case where the character is in the string, because you're not going to get to the end of the string. You're going to find it, and then return the correct answer. And so you may think this code works great and start using it, and then the first time someone tries to look for a character that's not in the string, your code starts crashing. So yeah, quick lesson there. Just because your code works for one set of input, don't assume it's correct. So what we're going to do now is we're going to write a program, a Java program, that's going to calculate a person's body mass index. And your body mass index, or BMI, given by the National Institute for Health and CDC, is weight divided by height squared, and then all of that multiplied by this magical number 703. I don't know exactly why this is 703. I guess it makes the numbers look better or something. But at any rate, that's what BMI is. That's the calculation, at least. We're going to write a Java program that will calculate it. So let's start by the things that we already know. We know that we need to type public class, and we'll give it a name. We'll call it body mass. And then we have curly braces, and within our curly braces we have a main method, public static void main string. There we go. Whoops. This is just something we know that we're supposed to do. We'll explain that particular line eventually. Okay, so we need two things. We need to have the weight, and we need the height. And for now, let's just assume that the weight and the height are given to us. We'll actually just put them as variables here. So we'll say double weight equals something. For now, we'll say 0. And double height equals 0. And we'll change those later. All right. And so we should probably say to the user what's going on. Let's say system.out.println, and we'll say something like body mass index calculator. And then maybe we'll say what the weight is. Weight it is, and then we'll use string concatenation, and we're going to say what the weight is. And we'll do the same thing for height. Height is, but we're going to say height this time instead of weight. All right, and then we need to do our fancy calculation. Double BMI is what we'll call the result. And as we saw in this lovely illustration, the BMI is weight divided by height squared, and all of that times 703. If we try to just do that, weight divided by height, and we'll square it by multiplying it by itself, and then times 703. This is an error. And that's because in Java, remember, dividing and multiplying are grouped together, so it's just going to go left to right. This will do weight divided by height, and then that whole thing times height again, and then that times 703. So remember, to override the operator precedence, we use parentheses. And that should match our expectations just like in math. All right. So yeah, we have that. Let's print it out. BMI is, and then we will concatenate, use string concatenation again, and just add the BMI value. Let's, for now, this isn't quite complete. Let's save this. Body mass.java, and then we'll go to the command line. We'll compile it. Java-C. Body mass.java. Uh-oh, we've got an error. And the error is that it cannot find this symbol, string. That's because I used lowercase s. It should be capital S. It refers to a class, so it has to be capital S. Okay, let's try rerunning the compilation. Compiling works now. Let's try to run it. Remember, when you run, you have to leave off the dot class. All right, body mass calculator. Height is 0, weight is 0, and BMI is NaN, which stands for not a number. Java has this like special thing when you do division with doubles, with decimal division. If you divide by 0, it'll give you this special not a number value, rather than being an actual exception as it would if you tried to divide an integer by 0. That's just a minor point. What we forgot to do here is put in the weight. So let's do, we'll say 200 pounds, and we'll say the height is 72 inches. So that's like 6 foot, right? I believe, yeah. So we'll save, and let's go back to the command line, compile it, and run it. All right, so with a weight of 200 and a height of 72, then our BMI is 27.12, a bunch of stuff. All right, let's do, let me punch these numbers into the National Institute of Health's online calculator just to make sure. And it says that the BMI for someone like this would be 27.1. Okay, so we got the correct answer, but that's not where we want to end, because the National Institute for Health also has this guideline where they say that anything, here, let me put it on my notes. Underweight is going to be less than 18.5. Normal is going to be 18.5 to 24.9. And then overweight is going to be 25 to 29.9, and then obesity is going to be greater than 30. All right, so using these values, let's punch them into our body mass calculator and print out a message that goes along with those. So if BMI is less than 18.5, then we want to print out that underweight message. And we want to have an else statement here, so we'll do else if. And now these are going to evaluate from top to bottom. So if it's less than 18.5, it'll execute this block. My next one is going to be if it's less than 24.9. 24.9. And the reason why this is okay is that if it's not less than 18.5, then it's going to go on to this one. We already know it's above 18 point, or it's 18.5 or greater when we get to this line here. So we don't have to check to see whether it's less, or whether it's, we could put that in as a check, as part of this check, but we don't really need to right now. So this is supposed to be like normal, whatever that means. And for the next block, if our BMI is less than 29.9, then overweight, and then our final one, we can do a check for this one, or we can just say, if we've gotten to this point, then we know it's got to be higher than 29.9. All right, so I think that's correct. Let's run this code. We'll compile it first. No errors. Run it. All right, so 27.1, according to the National Institute of Health, is overweight. All right, I think that's correct so far, but this solution that we've come up with so far has a few issues. One is that the decimal is not quite, we have this really long decimal in our output, and that's not quite what we want. We want it to be like 27.1 or maybe 27.2, or not 27.12. We don't want to have like a ton of decimals that just is kind of ugly. It's more information than what we actually need. So let's try something that we haven't quite learned yet, but we have learned how these things work. We're going to use string format. We know that string has a bunch of like object methods, but there's actually a static method on the Java, or on the Java string class called format. And what we're going to do is pass in a format string and our value. And this is kind of like advanced, or sort of advanced, but it's still useful to know. So what we're going to do here is, where we print out the BMI, we're actually going to say string BMI string equals string.format, and string.format takes as arguments two parameters, or at least the version we want to use. The first parameter is going to be the format string, and the second parameter is going to be the argument that goes into that format string. So we'll say format string. We haven't defined it yet, but we know our second parameter is going to be the BMI number. All right, so let's define our format string. Our format string is actually just going to be this with some special things inside of it. And we'll replace this with BMI string. What we're going to use for the format is a special pattern. And the pattern goes like this. You use a percent sign, and then we're going to use dot to F. And what this is going to tell Java is that this is a decimal value, but we want to cut it off after 2 places after the decimal point. These format pattern strings are, they can get pretty involved, but for now we're just going to do this to kind of clean it up. All right, so we're going to Java compile. And execute. And we get what we wanted. Our BMI is now being reported only to 2 decimal places. Okay, great. So now the question is, what if we wanted to run this for multiple people? Maybe there's 2 people. Well, let's see what we can do here. I think if we want to do 2 people, then we would just quite simply do the whole thing twice, right? So body mass, we'll say body mass index calculator, that's fine, but we want to say weight, we'll say person 1 weight, and then we'll say person 1 height, and then we'll say person 1 BMI. And then maybe we'll say like person 1, we'll say person 1 BMI class. And just as a sanity check, I'm just going to real quick compile this and run it. Okay, so body mass index calculator, person 1. Let's do a second person here. So what we're actually just going to do is pretty much copy the whole thing. But now becomes a problem. If we try to do this, then we need to say, well, this is now person 2, this is now person 2, this is now person 2, and then for all of these, person 2, person 2, person 2, and person 2. I think I got all of them. We'll save, and then we will compile. All right away we get an error. We get actually a bunch of errors, and let's look at the first one. It says variable weight is already defined in method main. That's because I copied and pasted. If you look here, this double weight on this line, it has the same name as double weight on this line. And so now I have to go through and make these things less ambiguous. So for the first person, I'm going to use weight 1. And then I'll use BMI 1. Alright, we'll use format string 1, BMI string 1, and we're going to have to make sure that we refer to the other strings. And now for the rest of these, we got to do 2. Make sure that all my variables are updated with 2. BMI 2, format string 2. All right, in the home stretch now. Let's save and see if I missed any. All right, it compiled. It should run. Okay, so yeah, we have the same person's values twice. So let's fix that. First of all, body mass index calculator. This is, let's make this stuff breathe a little bit. Let's put in a new line. So by printing an empty line, that'll put a gap between the 2 people. And let's change the values. Let's change this person to be 145 pounds. but we'll make them significantly shorter. Let's see, 60 inches is 5 foot. Let's make them 64 inches, or maybe 63. They're 5'3". All right, so let's try to recompile. Compiling worked, and try to rerun. Okay, so it says that person 2 is 145. Wait a second. It says that they are overweight. Now, I'm not sure that that's actually correct. Let me double check the online calculator. Yeah, 25.7 is in fact overweight. This thing is not very forgiving. In fact, for this person to not be overweight, I don't know, let's try 135. All right, so now person 2 is, their BMI is, according to the NIH, 23.9, which is the same answer we got, and 23.9 is in fact in the normal range, according to the NIH. Okay, so we have a solution for doing 2 people, but you can see that was really tedious, and I violated my principle, my don't repeat yourself principle. So let's look at what we did that was sort of duplication, where we did repeat ourselves, and try to remove that. Well, let's see, just the greeting message, where we say body mass index calculator, person 1 weight, and then person 2 weight, and yeah, let's change that. Let's make a method that will just do the greeting. So we go down here past our main method, and we'll call it public static void greeting. We're just going to print out a greeting. And our greeting is going to be the body mass index calculator, and then we're going to say person such and such is weighs this much, and then they are this tall. So this kind of raises a question. This weight variable, weight 2, it is in the main method. So I can't really refer to it because the scope is beyond this. So instead what we're going to do is we're going to say this takes parameters. We'll say, well, double weight and double height. So now these parameters need to be passed into the greeting method. And maybe we also want to do the same thing for the person number. And person number is going to be an integer. Now I'm going to compile this real quick and make sure I haven't made any obvious mistakes. I have. I used the whole word integer. It should just be int. Okay, it compiles, but we're not calling it, so let's call it in our 2 greeting sections. So here's our first greeting section. Let's do greeting, and then the person number is going to be 1. The weight is going to be weight 1, and then the height is just going to be height 1. That should take care of the greeting for person 1. But we need to do it for person 2 as well. And here's the greeting for person 2. So we'll do 2, 2, and 2. Save it, compile it, and run it. All right, it looks like the output was the same as it was before. So yeah, we have successfully taken something out of here and we parameterized it. Good, we're on a great path. So now let's parameterize a method that does this calculation. Okay. So we'll say public static. This time we're doing the actual calculation. So let's say it's going to return the result, which is a double. And we'll call it calc BMI. We know to calculate the BMI, we're going to need weight and height. So let's just copy those parameters from up there. These are not the same parameters just because I copied them, but we want to have similar parameters in this method. And our result is going to be similar to the calculation we've been doing above. Double BMI equals weight, height, and height. Great. And then we return the BMI. Now, when you see a pattern like this, if you are creating a variable, assigning it, and then returning it on the very next line, you actually don't need to make two different statements. You can just return the whole thing. And remember, returning won't return weight. It'll do the entire expression, and then once that's been evaluated, then it will return. So we're feeling excited, we're feeling frisky. Let's not compile it. Let's just actually try to use our method before we do the intermediate step. So we know that we need to pass in for a BMI2, calc BMI, weight first. Yeah. Oh boy. Weight 2, height 2. And we'll do something similar for up here where we calculated BMI 1. Calc BMI weight 1, height 1. Save, try recompiling, and we'll try running it. Okay, it looks like we're getting the same values, 27.12, 23.91. Yeah, that's what we wanted. All right, so let's move on to extracting something else. Well, there's this, the part where we simply print the BMI. So we'll create a new method called public static void print BMI. And we know for that we're going to need the actual BMI. Okay, so we don't need to have these two suffixes anymore. We can just use the actual proper names. And this looks pretty good, except that we're now like saying person 2. Well, we want to do like what we did up here, person number. And that also means that we should be accepting person number as a parameter for print BMI, just like we did for the greeting. All right, so that looks good so far. Let's go back to where we're actually doing it. Here's one place. Print BMI, and then we're going to pass in the person number and the BMI number. And now we want to do the same thing for BMI or for BMI2. Save, recompile, rerun it, and our numbers are still the same. So far we have not made any massive mistakes. All right, so our last step is this big conditional test where we see what class the person should belong in according to the NIH. All right, so let's call that print BMI class. And we know that from experience we're going to need the person number, and we're also going to need their BMI. So let's take the entire block and just paste it in. And now we need to update the names, the variable references, because they're referring to the old, like 1 and 2, or 2 in this one. All right, so that is good so far, except the strings aren't accounting for the person number. So let's just not do a ton of typing. Let's just copy and paste. Nothing shameful about this. And it looks like the variable names have all been updated. These big huge blocks we can just call print BMI class, give it the number and BMI2, so person number and the BMI number. And we should do the same thing up here. Only this is for person 1. So there we go. All right, let's, I've saved it, so let's compile it and run it. Okay, looks good. But now there is actually still some repetition here, even though I took all those things and put them in their own methods. And the repetition you can actually see here if you look at the entire main method, where for each person I'm doing the same steps. So let's create a method, and we'll say, we'll call it handle BMI. And handling the BMI is going to involve doing a greeting. It's going to involve calculating the BMI, printing the BMI class. Only now we want to refer to not 1, but the person number. So let's, whoops, I lost my highlight there. Let's copy it and paste it in. Great. So now person number should go everywhere where we have the literal number 1. And we can update these variable names to no longer have the 1 suffixes. All right, so we do the greeting, we calculate the BMI, and then we print the BMI, and then we print the BMI class. Going back up to our main method, we can actually now just do handle BMI. Here, let me put in empty line. Let's make our code breathe a little bit. With weight of 1 and height of 1. And I'm going to do the same thing for a weight of 2 and or weight 2 and height 2. So let's save it, and I think I made a mistake there. Yeah, okay, yeah, I think I missed that, and then I remembered it as soon as I switched over to here. So method, if you look at the actual error message, method handle BMI in class body mass cannot be applied to the given types. And it says that the required types are int, double, and double, but the types that were found are double and double. Okay, that is because I forgot to pass in the person number. So person number 1, person number 2. So previously I was just doing double, double. I need to do integer, double, double. Because if you look at the signature for the handle BMI method, it requires in its parameters an integer, a double, and a double. Let's save it and recompile and rerun it. Okay, cool. I think we've got this. I think we've removed as much repetition as we possibly can. There's a few small improvements that we could actually do right here. One is that like we declared these variables and then we use them. There's not really any need to do that. You could actually just put in directly 272 without declaring the variables at all. And the same for down here, 135 and 63, not 163. It's kind of not necessarily a huge improvement. But yeah, you can see that we get the same values. It's logically the same. Okay, so there we go. Now we have completely removed the repetition, and we've used a lot of the principles that we've talked about, return types, parameters, things like that. Great, wonderful example. Thank you for watching session 4, and I look forward to seeing you in our next session.